Hi, grade 8s. Today we're going to do the speed ratio lesson. So we can turn to this in your booklet. Okay, so I'm going to do an example. We would have done a little demo. I'll try my best to do it here. So what we have is a situation. We have two pulleys, two double pulleys, so it's 4 pulleys. And I'm just going to draw the rope around them. So they're holding up a weight. And then the rope will go around like this. So you'll pull down on the rope. Okay, so what we're going to find in labs is that you're going to have to move the effort force a lot further than the load is going to move. And the difference between the two is called the speed ratio. So just to start, before we start here, what is the TMA or the mechanical advantage of this pulley system? So it is equal to the number of supporting ropes. So you would count 1, 2, 3, 4 supporting ropes. This one's going down, so it doesn't count. So the answer is 4. Okay, so we'll do a little experiment here. So what we would do is pull down on this rope a certain distance. So let's say we pull down on it 4 centimeters. Then we would measure how far does this load move, and what we would find is it would move 1 centimeter. Okay, then if we try moving this effort force 8 centimeters, we would find that the load would move 2, so from here to here, so 2 centimeters. And if we move the load 12 centimeters, so from here to here, then we would find that the load would move 3 centimeters. It would go from here to here. So you notice that it's always the effort force divided by 4 is equal to what the load force is. Interestingly, that the number of supporting ropes also was 4. Okay, so we're going to do some examples on how to calculate effort distance. Or speed ratio, sorry. Speed ratio is going to be equal to effort distance divided by load distance. Just get a pen out. Okay, so here we have the same pulley system as I just showed you, and the effort moves 20 meters and the load moves 5 meters. So the equation SR equals ED over LD, you would write that out every time. So we write speed ratio SR is equal to ED over LD. And then ED is effort distance is 20 meters. And the load distance is 5 meters. So speed ratio is equal to 4. So 20 divided by 5 is 4. Meters cancel. So then there's no units for speed ratio. It just means that effort always goes 4 times farther than the load. Okay, you can also do this same speed ratio with other types of simple machines. So here we have an inclined plane, a ramp, and the load actually moves 16 meters, but the effort only moves 8 meters up. So we still use the same equation. SR is equal to effort distance over load distance. So that would be equal to 16 meters divided by 8 meters. 16 divided by 8 is 2, and the meters cancel. Okay, here we have another pulley system. So the effort's moving 9 meters and the load's moving 3 meters. So speed ratio, you always have to write out the equation. Effort distance over load distance. And then you have to write your numbers with the units. So 9 meters divided by 3 meters. So don't forget the meters. And then 9 divided by 3 is 3. So in this case, whatever the load moves, the effort always moves 3 times the distance. So if we had say this extra question here then, instead of moving 3 meters, what if the load moves 5 meters? How much would the effort move? Well, it's always 3 times, so then 5 times 3 is 15. So then the effort rope would move 3 times 5 meters is 15 meters. Okay, and then here we have a pulley system. So the effort moves 4 meters and the load moves 2 meters because the fulcrum's not right in the middle. So speed ratio is equal to effort distance over load distance. And then that would equal 4 meters divided by 2 meters. And 4 divided by 2 is 2, and meters cancel. Okay, so you should have this as your next sheet. I hope you should have copied all of these examples down. And then you're going to, right now, then pause the video and do all of these questions. Don't cheat and move forward because that doesn't help you to learn. Okay, so I'm going to give you a minute, pause, do the questions. Okay, now hopefully you did those questions and come back to check your answers. So in number 1, the speed ratio is 2. Number 2, the speed ratio is 5. And also you're showing all 3 steps. Number 3, the speed ratio is 3. And number 4, the speed ratio is 4. And then the extra question, how far would the effort force move if the load moves 5 meters? The answer is 20. Okay, so you're going to do both of those sheets, make a picture or scan it, and then send it to me, preferably in the Dropbox. So submit it in the Dropbox. If you're still having trouble with Dropbox, I do have a video I did a few days ago on how to use the Dropbox, so please watch that and hand those in. Thank you very much and have a good day.